I welcome Tanvi for this podcast. This is a kind of a podcast where I always just believe that there's no barrier to your creativity, there's no barrier to the future that you want to build, and there should be no barrier to the future ready engineer that you are supposed to be building. Because right now, there is no reason for you to say that, hey, this is what I am doing, this is what I'll be doing. There's no place for you to chill and say that, hey, my data science job is going to be so easy. Forget the fact that you need to be a data scientist, you need to be somebody rich, but just get to know the fact that you are supposed to learn every single day. And I'm proud to say that Tanvi is one of those people where I met on LinkedIn, and I told to myself, okay, what can I do without, as an EC student, without saying the reason that I'm not an EC student, because I've told it very long time to people. So I just want to just educate myself beyond what I could do over a course of time today. And thank you so much, Tanvi, for giving me this podcast. It means a lot.
It's my pleasure being here, and thanks for this opportunity that we are having this discussion today.
Yeah, Tanvi, let's just discuss this journey as a student and as a professional, because your journey is something which is a little vague when compared to mine, but not like you're not dedicated about the data science, and you didn't know a little bit of an data science at all. But what really
Right.
had a paradigm shift in your mindset when you wanted to pursue this data science? That's what I really wanted, because a lot of times we juggle around with this mixed feeling like, should I get in? It's going to take time. Should I not get in because there is no scope tomorrow? There's a lot of things. So just educate me on what was your journey as a student and as a professional.
Yes, sure. So it's good that you have started with this particular question. I will start with my background first. There's one thing which we both have in common. That is, I have done my bachelor's in electronics and communication engineering. So I completed my bachelor's, and I had a dream, a passion to do some kind of graduation from IIT. During my time when I was applying for BTech, I didn't get I couldn't clear the entrance exam, the IIT JEE exam. But somewhere in the back of my mind, it was there that I need to pursue some degree from IITs within, which are the premier institute within India. I followed my dream and I did my master's from IIT Kanpur. And it was during that time, like during my masters, I got introduced to the world of data. Coming from a background related to electronics, I had no clue like what is data or what is the power of it. And given that the industrial age today is the digital age, or the age of the data, and there are a lot of industries who are currently working on data and are utilizing the power of data. They take a lot of decisions based on the data. Now they very frequently say the term data driven decision making, right? So they are doing a lot of impactful work, a lot of value is being generated with data. But I had no clue like before getting started with my masters. I took a lot of courses during my curriculum which were related to data science, data mining. There were topics related to coding as well. We learned R, Python, and these are just the tools. I mean, there's a lot of a lot of skill set which you need to become a data scientist. But I was just getting started with it. Then I did, as a part of my master's curriculum, we had to do an internship, which gave us the exposure to the real world problems. And it was also pretty interesting, like building a predictive modeling use case using Python on a real world data. That was something which was challenging. First of all, like normally when we do any courseworks or any projects within the courses, we deal with the data which is publicly available, and we don't understand like for the industries it's not the case. They have data lakes, data warehouses where the data would be residing. So you need to understand how you would be doing the extraction. Sometimes it can happen that you being a data scientist, you are taking care of the end-to-end process within data science, meaning starting from talking with your stakeholders, understanding their challenges, the pain points they are having, and formulating that technical problem into a business problem. But during your coursework, you won't get that idea, or working with the Kaggle platform, you won't get that exposure. So during my I would say the internship which I was talking about, it gave me some exposure, a bit of it, like related to predictive modeling and solving any use case and any industrial use case, which was solving that use case and learning about the courses. I was very fascinated with the world of data. It was pretty overwhelming as well. And another thing was, I had some inclination towards mathematics when I was in my class 10th or 12th. I used to love maths. That was a point in time. Still, I loved working with numbers and doing interesting stuff with the data. So I could realize my passion and my interest towards this field because of my love toward mathematics, and also I loved coding. Even if I was from electronics background, you will find like people hesitate who are from mechanical or electrical or electronics background. They hesitate when it comes to coding. It is not that difficult, and I used to enjoy doing coding. I had learned Java and C++ during my bachelor's curriculum. So both of these factors, I mean, having some inclination towards coding and mathematics, made me fall in love with data science. I can say that. And then I continued, and now currently I'm working as a data scientist in my organization.
That's the toughest decision to make. It's not like you can be a data scientist in 6 months or 5 months. It's really impossible to be that. What you can do is you can have some basic kind of fundamental understanding, and then you can just go for a job, understand what is that production problem statement that you get. Your Kaggle is something which is cool. It's good enough till you write an amazing paper. It's good enough until you write an amazing algorithm. But when you go for an industry based, like if it's like more of an tentative task, I think probably it's going to be like something like, hey, can you really solve this problem? Simple as that. And I just wanted to understand, like, you know, there was a paradigm shift in your mindset because when you joined, of course, you knew some coding, but a data scientist is different. Because I would say, like, participating in a lead code competition is different, participating in Kaggle is different, participating in any of the hackathon is different, participating in any of the interviews are different. But how to really get to know what is happening in the industry and how to just go with the flow of what you really want to also, because a lot of times we might lose that mindset, like, hey, should I do this, should I do that? Because a lot of times some people are like, if you do lead code you get data science job, but that's not a part of it. But what are you really able to really have an aptitude to really solve that problem? Forget the fact that there is huge modules, you still use Stack Overflow for coding. That's no big deal. But like, how do you
Right,
architect a
right.
solution tomorrow's for the tomorrow's world? That's what I really wanted.
Okay, so I would say this is a pretty big question. It would need a lot of answer. So let me take step by step and let me know if I have missed any part of it. So first of all, I totally agree with you what you said. Like nobody can be a data scientist in 6 months or an year. It is a continuous journey. You evolve over time. The technology landscape of data science is evolving over time, and you will see people who have been within the industry for as long as 10 years also won't claim that they are the perfect data scientist or they are the ideal data scientist. They are also still learning, given that there is a lot of research happening in this field every day. If you Google or you go and read some research paper, there would be something new which you would be learning. This is a field which requires continuous learning. Your learning never stops in this field. Like somebody who is fresh out of a college might think that I have done my bachelor's, now I would be working in an industry and it's fine. I mean, I don't have to learn anything new. That is not the case with data science. Every day you have to keep up keep up with the current technology, current changes that are happening. This The technology landscape of data science is continuously changing, and a person who has a growth mindset, who has a mindset of self learning and continuous learning, can be someone who can work in this particular field. And another thing, like you said, uh, I would define data scientist in my own way. The way I put it is, a data scientist is a person who is curious, who don't hesitate to ask a lot of questions, and a person who is a problem solver. who is willing to apply multiple approaches to a given problem statement, who can think from different perspectives. We need someone who has these two characteristics, basically being curious and a problem solver. And if even if you don't have a technical background or a coding skill set, you can still be a good data scientist with these two characteristics. Now, coming to your another part of the question, which was like people are nowadays working a lot on the hackathons and Kaggle problems, which is good. I would say learning through these platforms is a good habit. It's good to create a good portfolio doing some projects out of them. But you need to understand there's a difference between the Kaggle world or the hackathons, like the publicly available data sets, and the real world or the industrial use cases. First of all, what happens is within Kaggle, the data set that you are getting is already prepared for you. A lot of the analysis, lot of the data preparation has been already done, and you are given the data set. And then on top of it, what you do as a person is basically you are trying to build some cool algorithms based on the state of the art. You will say that let's say nowadays the GPT-3 is very popular. I want to build some model using that. Your entire focus is to learn the new algorithms. But when you go to the industry, this entire picture changes. You need to understand, first of all, the use case which you are trying to solve. Initially, you will talk a lot with your stakeholders, the people who are going to take decisions based on the models that you will be creating. You need to understand their pain points, the problems they are currently facing. You need to identify, is it the right use case where I can apply machine learning? Sometimes what can happen is your stakeholders might be very interested in building a machine learning model. They can come to you and ask you, hey, let's build a machine learning model. But you need to understand, does the use case really require a machine learning model or not? You have to convince them. Nowadays within industry, it is very difficult to convince people why machine learning is not needed. That is another question. I mean, altogether, it's a different game. You need to make them understand, okay, this case, we don't need it. Now, taking the example of the case where we need machine learning algorithms to solve that particular use case. First of all, you will start interacting with the business, understand their pain points, and then you will formulate the business problem into a technical problem, which could be solved through machine learning. You need to do a lot in terms of understanding the data, how the data is being collected currently. There would be a process through which the data is being generated, and the data would be residing somewhere in a cloud database or maybe some data lakes that the organization is maintaining. Once you get the data, a lot of your time would be spent in data preparation, which people don't understand. Given that the Kaggle world is not involving this particular step, there's a lot of time. Almost I can say 80% of our time is spent in doing the data preparation, the feature engineering, understanding the business and converting that into some derived features which could be fed to the model. It is very important to give a lot of emphasis on the feature engineering part. Sometimes what you will see is building a simple model can have a better accuracy than a model like deep learning neural network, because the feature engineering which was done was pretty good. The features which you created were able to give a lot of signal to your model, due to which the performance of the model was pretty good. So that is one learning which I have seen, like in my experience. Then another thing is which people people who are just getting started or are transitioning into this field don't understand is my model is not my Jupyter notebook. I use Jupyter notebook to do the development, to do a lot of experimentation and running the iterations or doing a rapid prototyping. I have done that in my Jupyter notebook. But is it something which could be used by the end users, by my stakeholders? Will they be using the Jupyter notebook? No, right? There would be new data which would be generated through the processes, and you would have to create a scoring or an inference pipeline. You will have to deploy the model into production so that it can create certain actionable insights for the end users. Your stakeholders would be then able to use the models once you have deployed that into production. Now, when you are thinking about deployment, it's a whole another chapter in the field of machine learning. I mean, Developing a model is, it takes a lot of research. You do a lot of back and forth iterations. Now coming to this phase, which is deploying your model into production, it also takes a lot of your time and effort. So a best practice is, whenever you are developing a model, make sure that your model is scalable and it is maintainable, meaning once you move it into production, many different users can use it, and it is easier to maintain such models. So you need to take care of such aspects. And when you are talking about deployment, there are certain best practices related to software development that are being adopted in this field. Like, you have to be writing unit testing for all the functions or all the models that you have created. You need to write some unit tests to make sure that nothing breaks when you are deploying things into production. You have something called as integration testing. Then you have code documentation. There would be an entire flow which you would create, so that if somebody new takes over the project, they have a clear understanding of what the code is doing and how the code is being maintained. Then you have something called as code optimization. Normally, people, like when we build models, we don't think about that, right? We don't think about optimizing the model, or how we can do parallel processing, how we can do scaling. It helps us a lot when we are having a new data, we have to score it. The throughput or the latency which would be involved when we are scoring the new data, it would be reduced if the model is optimized. So all these software development related practices we need to take into our mind while we are developing the model. And another part I think which you asked was related to, um, basically, what should be the purpose, right? When we are starting with a data science project, we should keep that purpose in our mind, why we started with this project, and what would be the business impact that we can have through this project. What would be the value realization? Either we are going to either we are going to save something in terms of the cost, the revenue. We might be minimizing the revenue, the cost optimization. Or maybe it could be the case that we can have some gains as well. I mean, we might be able to create some profit out of the use case that we have solved. Or maybe we are able to solve some time. Let's say earlier the process was manual and it was consuming a lot of time and resources in order to do the same thing. But with the help of machine learning, we might have reduced the time as well as the value, the impact that the models are giving. So you always need to think up like whenever you say that your model is doing good, the accuracy of the model is good, you need to relate it to some business metric. Meaning, in terms of some gain, some cost reduction that you are doing, always think in that manner. Not only about the accuracy. Accuracy is not the only aspect that you should be looking at, or the model performance is not the only thing. You need to look at your code should be scalable, it should be deployable, you should be able to track the performance over time, and how it relates to the business metric. How is it creating an impact for the business people?
That's true. That's true. Because a lot of times when, it's not about that also. It's like you are not just doing about this Jupyter notebook thing, you are just getting high paid salaries. It's not about that Jupyter notebook at all. The Jupyter notebook is just like a part of it. Like Kaggle has amazing notebooks,
Correct.
man. If everybody who is a master or a grandmaster or something, if everybody starts going there, I think probably everybody should have an amazing life actually. But it's not about that. It's like the production system is very, very unique. But I wanted to understand, like, what was the first fundamental understanding that you had when you really entered this domain of financial as well as the machine learning, because that's what you are juggling around with right now. Because subject domain knowledge is something which we might not think about, but what is that all about when you are working on one subject and one domain and one real architected solution, but you are trying to break it, make it, what is it all about when you need to have a fundamental understanding? How do you approach a problem statement? That's my question actually.
Okay, that's an interesting question, I would say. First point which you mentioned, which was very correct, and I totally agree with that, that when you are working with any machine learning use case, you need to have a good understanding of your business, the business domain in which you are working. You need to think as a business executive why this is happening, how much impact it is going to create, what will be the end goal, what will be the users who would be using it, how is my solution going to impact the users. So all that stuff, and having the business knowledge, basically the process around it, how the data is being generated, the current process which is existing, what are the challenges and the pain points with it. Always you have to start with this thing, understanding the business pain points. So whenever you do work in any domain, you need to get a clear understanding of how the data is being generated, what is the relationship between the different data sources that you are having, the business logic behind it. In finance, it's a pretty big process that we deal with. We currently the domains within finance also, there are I mean multiple use cases which you can work on. So I deal with cash flow cycle, and cash flow is very important for any industry. You need to understand how much how much amount is getting in and how much amount is getting out, basically your account receivables and your account payables. There's a lot of terminologies, there are a lot of KPIs within finance which we deal with. Now, having an understanding of these KPIs, we need to understand how they are correlated with each other. They are not working in silos. They have an impact and an interaction within themselves. So we understand the entire process from the business, currently how it is working, what are these terms, how the money is coming in and how the money is going out, what are the different terms involved. Like there is something called as a payment term. When you create an invoice, what happens is there will be certain time after which that invoice would be getting paid. It also have some impacts on the financial KPIs. And normally within finance, the use cases which I have worked are related to forecasting. We are pretty much interested in forecasting these numbers, like what would be my account receivables in, let's say, the next quarter, or 5 quarters down the lane, which is a long range forecast. So you need to understand how these forecasts are impacting my business. So that business understanding is, I mean, very much needed whenever you are working with any use case in the field of data science. You can't say that I will only look at the technical perspective of it. That is basically building cool models. That is not what a data science is about. So you need to take care of your business perspective as well while you are developing your models. And another thing which you said was like, when I work, actually, like, I would say I have been very fortunate to get this exposure of developing models, of deploying models into production. I'm pretty new to this field, I would say. I'm a pretty, I'm young in this field. It's been around 5 years that I have been working in this field, and getting an exposure to deploy a model is something. It takes time. It takes time for you to, build some product. Normally within the industries, you will see that people start with POCs. There will be a lot of POCs which the team would be working on, and there will be only few products or projects that will go into production. You normally built up some minimum viable product and you realize that, okay, this won't be that helpful for the business, so you stop at that point. And there will be few products, like I said, which will be moving to production. Now, one of my projects has, we have created a proper end-to-end ML system, and we have deployed that into production. And there has been a lot of learning which came when we started thinking about this project. We started thinking about the how we will enable the data. Basically, how will the ETL of this particular product will look like? Where will be the data residing? Then how do I make my model talk to this data? How do I deploy my model? How do I package my model? Basically, I can create an API out of it. And then when we talk about deployment, either it can be on-prem or on these cloud services. Nowadays, like, industries are moving to the cloud servers. But for us, we have currently we have deployed this model on-prem, and we have, what we have done is we have used the container technology like Docker. We have Dockerized the entire solution, packaged it, and then we have moved it onto the on-prem server. It makes our life a bit easier once we have containerized the solution, because you have all the environment that is being needed by your application is already present within that container, and you don't have to worry about anything. I can just take the container and ship it to another server. The process becomes pretty easy. Only challenge which you might have is if you're trying to deploy it on the cloud server, the infrastructure is there is a bit different. So you might have to change your architecture a bit. That a bit of an effort might be needed at that end. But apart from that, I mean, it's pretty uh, it involves a lot of learning when you are talking about deploying your model. And also after your deployment, I mean, your job does not end after deploying the product. There's another chapter after there, which is called as performance monitoring. You need to keep a track of the performance of your model. What can happen is your model performance might deteriorate over time. So you need a framework established over there, which will keep a track of how your model is performing in future. And if there is any kind of a data drift or concept drift in your data, you should be able to identify that. In this scenario, your model has to be retrained on the new data which has come into picture. Then only it will be able to do good predictions on the unseen data set. Because there could be a case that the process through which the data was generated has changed. So you need a monitoring framework. So remember that, like, Jupyter Notebook is not the end of your model development cycle. There's another kind of challenges that you will face once you deploy your model, or once you are talking about the monitoring the performance of your models. So just remember, I mean, don't only think as like I just need to focus only on the model development, getting a good accuracy. You will see many industries which have models deployed into production which are not giving you the best accuracy. Okay, so basically the target is not to achieve the model with the highest accuracy, but something that is effective in terms of cost and time. So, you know, there's a classic example of the Netflix recommendation system. Netflix has organized a competition wherein what they did was they had a prize money allocated, like somebody who would participate and win the prize. They will give some money to those people, right? And as of now, in the case of Netflix, they have deployed the second best solution into production. Even if the accuracy of that model was not good as the first one meaning which has the highest accuracy, the second one was deployed in production. The only reason being it is cost effective and time effective. So you need to look at different parameters when you are thinking about deploying your model into production. I hope that I have answered your question here.
Yeah, yeah, that's true. And also, there is a change in the algorithms every single day, and there's change in
Correct.
TensorFlow every single day. I don't know why. Like, probably if I do pip install minus u TensorFlow, I'll be like, should I change my code base once again? That's the amount of that's the amount of fear that you get every single time when you go on deploying the model. That's how worse the TensorFlow. But PyTorch has its own charm in the world of AI because PyTorch is like very stagnant. Like even if you have written the code 2 years ago, like if the if the module is optimized and your computer has some drivers which are absolutely running, it's absolutely fine. But what about this PyTorch and this TensorFlow thing that is going behind? Because a lot of times it's not about that also, but like there are people who have used Kefi in their production system. Like there are people who have also worked on all the frameworks actually. I've talked to a guy who is an amazing person in terms of ML, but he just told me there's no difference between any of these. Fast AI still remains the same, TensorFlow still remains the same, but the only thing is that algorithm. So, what do you think about this shifting phase in which you are seeing these algorithms? Because that's very worse. To just imagine that there's a code base which has to change at every given point. What's that all about? How do you tackle that problem statement?
Right.
Because in production, like probably some guy might have had a different system configuration. There is a different way in which the results come in, and even in our research also we don't validate the data until like 1 week before the paper submission. Afterwards we start doing all that validation. So how is it all about when it comes to that production system?
Yes. So when we are talking about the production system, the way we have deployed our application is basically, like I said, we have containerized our solutions. So in that case, what is happening? The environment, basically all the packages and all the dependencies that are needed by our code are present within that container. It's a separate container. Let's say what is happening, like you were saying, I need a particular version of a particular package. Keeping it very simple, if I'm talking about, let's say, pandas package, which everybody is very familiar with, right? Now pandas is also evolving, but in our case what we are doing, we have a specific version which is being installed, which is being deployed in this particular container, which will be present in this particular container. So we are always referring to that particular version. So we don't have this struggle. Like you said, if something changes, there would be a new version which would be released, but we are always referring to the older version. Let's say, I think Pandas, it's 1.4 or something is currently being used. I'm not very sure about the version which is being used currently, but let's say we are using, for an example, if I'm using a version 1.4 of a package, in this environment, in the Dockerized container, only that package would be present. So I don't have to worry about if in future there is a new version which is coming into picture, because in my requirement.txt file, always I would be pointing to the 1.4 version. So it will always refer to that version. So this helps us a lot. I mean, using the same version, not upgrading the versions. If we do that, then there are a lot of chances that our code will break, and it's very painful. I mean, just to think about it, thinking about a production code breaking down, it creates a lot of pain for you, and there is a lot of challenges. I mean, nobody wants that, right? So we have this particular way through which we face this problem, is to make sure that we are always referring to the version which was being used in development. So what I was saying was, once you have your code in production, basically once you have Dockerized or containerized your solution, you are always referring to a particular version of a package. For example, let's say there is a XYZ package which I was using during development, and the version of the package which I have used is 1.4. Just for simplicity, I'm just giving this hypothetical example. Now, in this case, what I'm doing is, in production also I'm using the same package. So there are, I mean, very less chances that my code will break just because of a package dependency, since I'm referring to the same version. If, let's say, for an example, there could be a time duration of 6 months from your development phase to moving things into production. Now, in this case, it could happen that there is a new version of the package which came into picture, which is much more stable and reliable. So my suggestion would be, in this particular scenario, to change the package version to the stable version, because your model is going to stay into production for another 2 to 5 years. You are talking about the future. So you need to be very sure that the version which you are using is stable and reliable. And if it has come into picture, I would say that go ahead and use that. But once you have deployed, you won't have to worry about it, since in the container environment is already created, it is fixed. You will be using the dependencies, the versions that you have mentioned in your requirement.txt file. Let's say you are building the entire solution in Python. There is a file called requirement.txt which will have all the dependencies which you need for your code to run. So that will remain constant. I mean, that is not changing. So irrespective of the changes in the versions of the package, you don't have to worry much about it, until and unless your model performance is deteriorating, or there's a data drift. Then you go and retrain your model, and then again you might have to go through the entire cycle of development and doing a lot of experimentation. That is another case. But due to package dependency, I haven't seen. I mean, if your solution is containerized, in that case, it won't be much impacting your work.
No, like this microservices has really changed the way in which we are architecting any solution. But there is a huge difference in the medical system being architected, because there has to be less error. And banking is something which is as critical as that, because you need a lot of optimized code, because there is always a trade-off that we always play with. If you want more of security, you just have a trade-off with the performance. Or else, if you want more of performance, make sure that you are ready for the security patches that is going to happen at every given point. That is gradually going to deteriorate the performance, because when I see something like you run a website on a VM, there's a different story behind it. You containerize it, just try to deploy it, there is a different story for it. And code base has a different story for it, because of course there is secrets in GitHub, and there is key vault, there is Hashika vault, a lot of things. So how do you think that this phase of technology is going to change over the course of time? How do you actually perceive the technology in the future? Because a lot of times, your story might really motivate us to study beyond it. Because until last week, I also didn't know what was the actual potential of Pulumi, because I was just doing webinar for the sake of it. But I will say what it has a lot of potential. So how to understand what is the requirement of a system? Because a lot of times when we are talking, we just go behind a person who has already done that. But probably there are more simpler ways that we can architect towards. So what should be the approach when you are architecting a very good system with simple approaches?
Right. That's a pretty good question, I would say. And I would answer this in terms of machine learning, since this is the area I'm very close to and I'm working in this field. So, like you said, what would be the future of systems? Let's say, what would be the future of the AI or the ML system? Now, nowadays, there is a lot of research which is going on an aspect called as ethical AI. You might have heard this term, ethical or responsible AI, which is basically it refers to making your machine learning models or the AI system which you have created responsible. It has four aspects associated with it. One of them is related to fairness or the bias which is involved in your machine learning algorithms. You need to make sure that your models are fair and unbiased. Then the second aspect is related to explainability or the interpretability of your models. Nowadays, there are many black box models which are being used into production. But the problem with them is they are not explainable. The end users which are using those models can't trust those models. They want to understand how my model is getting to a particular output. When it is saying something, why it is saying so? When should I trust my model? These are the questions they have when they are trying to use a model which is deployed into production. Then the third aspect of it is related to data privacy. There's a lot of concerns in terms of what data is being used when you are training your models or what all attributes is it capturing. So within European countries, if you would have heard about it, there's something called as GDPR, which has been launched to make sure that the data, there is a law related to the data privacy. Also, an individual has the right to know if there is any data which is being related to him or her, what data is being used for the purpose of training the model. Like in the case of banking system, like you said, normally machine learning is used for the loan prediction or like understanding who is eligible to give a loan or a credit card. Now, let's say I have been denied a loan, but I can go and ask the bank on what parameters have I been denied the loan. If they are using machine learning models and they don't know how to explain it, they won't have an answer for my query. So nowadays, like people are very much interested in knowing why why a machine learning model is saying what it is saying. And then the fourth aspect is related to the data security. I need to make sure that the data which I'm passing to the microservices, like you said, the transformation of sorry, basically the way the data is being transported to the APIs, that is secured. It is if there is a hacker who is trying to hack the system, they can easily get hold of that data. It's pretty sensitive, right? So you need to make sure that you have a data security mechanism as well involved in the ML system that you have built. So I see in this way that your model should be compliant. You should have a framework of explainability around the model. It will help your audience or your stakeholders to bring a trust and adopt those models. Nowadays, there's a lot of challenge within the industry that people who are the action takers, they don't trust the model. They are not ready to accept it. First of all, the reason being that it is not explainable. Second is related to the mindset and the skill set which is needed to use such models. First of all, you should have an open mindset. You should be ready to adapt to the new changes which AI or the machine learning systems are bringing. They are going to change the processes, the traditional processes that the people are used to working with. And the second thing is the skill set, meaning those people should be educated. They should have the right resources. They should understand that machine learning is not magic. It is basically at the end of the day mathematics which is happening on top of your data. There are certain kind of calculations which are happening. It can't create magic. So that understanding is needed. And then only people and the explainability part of the models. And then only people will be able to adopt to the AI systems. And then your machine learning models will be a part of your entire business process. Yes.
No, but like, I want to ask you this one question. What if the production breaks? What is the chaotic environment that will be created when the production breaks? I know probably you might have faced it once in your lifetime because it happens. for every person. And there'll be a lot of meets after meets, and they say, what is the solution for this and the things like that. So I wanted to understand from your side, what is it all about when you are having an study system which breaks down all of the sudden over a course of time?
So I might tell you it's a nightmare. I mean, if something like that ever happens. And in my case, I would say I have that exposure in my previous organization. I still remember, I mean, over the weekends, our jobs used to run over the weekends, and we used to get call 3 in the night just because something has failed in the production. And the team who was in charge, the support team, they had no clue of what went wrong. And it was very difficult, I mean, just to wake up and look at something has failed and to fix it up. Because what happens is, let's say when you are running something in production, you will have a lot of dependencies. And if let's say you have a flow, a very simple flow, which is script A, script B, and script C, they run sequentially. Let's say you have something failed at first point itself, i- and nothing can run after that. So you have to be very cautious. I mean, whenever you are writing your code, you have to do a lot of unit testing and integration testing to make sure that nothing is failing. Apart from that, what happens is every time you roll back a new version, you need to come up with a fallback mechanism as well. Let's say something failed, and it will take some time for you to go back and fix that issue. You should have a mechanism to roll back to the previous stable version. That is still okay. I mean, instead of always targeting for the new feature, it might take some time. It might take some time for you to fix it up, which is totally fine. Just have a fallback mechanism in place, which will always refer to the stable version. So when you, what it will do, it will give you sufficient time for you to go ahead and fix the bug and come up with a proper solution. And meanwhile, it won't, if the data is needed for the machine learning models or the output is needed for some other processes, it can happen that it is pretty urgent. You have the stable version and you will get the output from that.
No, that's the part of DevOps, right? That's what DevOps is all about.
Yes,
It's not too complex
right.
also, but like it seems to be complex because there is a lot of moving parts in the
Correct.
DevOps itself. So that's what it is. So I wanted to last question. I just wanted to ask you this, like how to learn something, because a lot of times it's a gradual growth and it's dynamic. It's like it was dynamic from the beginning and it's still
Correct.
dynamic right now. The data science is not data science. It was actually probably something known as data analytics, data understanding. That's what they always were, but like now it's a different story. So I just wanted to know how to learn something, because there is always an opportunity for you to learn at any given point. Let you be the best in the industry, but there is an opportunity to learn from the even the worst nightmares that you never thought would come up with that. Like when you see of Keras actually abstracted the way in which TensorFlow was complex, right? Francois Cholity came in, and that's a different story. So I just wanted to know how to learn something in the world of data science.
Yes. So I totally agree with the point you said, which is AI and ML is a dynamic field. It is continuously evolving, and it is very difficult to keep up with the pace at which this industry is evolving. I mean, even if you talk to people, what you will find that everybody within the industry is trying to learn something or the other day. It's a continuous journey, a continuous learning journey, and most of it would be self-learning. You have a lot of resources nowadays which is available online. Google is the answer to all the questions which you have. Earlier, there were days like people didn't have proper resources. If something new came into picture, like when TensorFlow was launched, at that point in time, we didn't have much resources to learn it. But now, in the present point in time, there is so much content which is available online, which anybody can go and it's freely available. You can access those resources. There are YouTube channels. People are posting regularly on LinkedIn. There are blog posts. Then you have courses on platforms like Coursera, Udemy. If somebody is interested, they can definitely go ahead and learn from them. So one thing is learning, trying to identify some method through which you can learn. It could be like watching videos, reading some research paper, blog post, or talking to individual people who have been within the industry, finding a mentor whom you can talk, an industry expert from whom you try to understand what have been the challenges that they have faced and how they overcome that. That is one way of learning. The second thing is, once you learn a concept, it's not only about the theoretical knowledge. Within data, within the field of data science, you need to make sure that you are getting your hands dirty. You need to implement those things as well. So whenever you come across, let's say, a new function within a package in, let's say, in Python, you come across a new package. Nowadays, there's a package called as Lux, which will do entire EDA for you. It's pretty new. We don't use it. There are reasons behind that. But my point being over here is that something new has come up. I read about it, but I don't use it. I won't remember it. I don't understand what are the challenges. When we start using it, then only you will get to know about the challenges which it has. Or let's say it's a pretty good thing to be used. You will only keep it in mind once you start using it. Another thing is, once you use it, you will know the value which is being generated. Basically, is it good to use this thing or not? Is it and once you start doing hands on, you will think about different approaches in which a particular problem can be solved. So another thing would be, once you learn it, you need to apply in terms of like doing taking a publicly available data set and applying that particular approach on that. Another way to apply it could be, you might teach someone. Sometimes what happens is, when we teach someone, the concept that we have learned, that becomes very clear to us as well. It is kind of printed in our mind. I mean, it would get printed in our mind that this is how it works and this is what it means. So that is another way of learning. And when it comes to keeping yourself updated, I would say there is a lot of material. It is pretty overwhelming. You can't learn everything within this particular field. So make sure that whenever you are targeting something, finish it up and then start with the new thing. Don't get confused that I need to learn SQL, I need to learn TensorFlow, then I need to learn something else, and I have started all the five things in parallel. That won't take you anywhere. Just first start with something, have a goal that I want to achieve certain level of skill set within this particular field. Let's say I'm starting with SQL. I need to know this things. Have a target in your mind. Once you achieve it, then go to the next skill set. Because here the technology is continuously changing. Nowadays, people are using Python. Few years down the lane, people might be using Julia or any other language, which doesn't impact you. I mean, once your fundamentals are pretty clear, irrespective of the language or the framework or the architecture, you can grab it pretty easily once you have an understanding of what you want to do, what you want to achieve.
Yeah, that's true. That's true. I think, Tanvi, thank you so much for all the insights that you gave today on the world of data science and machine learning. But it's not about that. Like, you have been in the industry for a very long time. You've also seen how the production system breaks and makes you money. And I think that's the best part about interviewing data scientists today, because they have a lot of insights on what should be done, what should not be done. I think, thank you so much, Tanvi, for this podcast. It was amazing talking to you.
Same here, Vishwas. Thanks for having me.